Good morning, my dear students. I hope my voice is clearly audible and my PowerPoint slides are visible to you.
Yes, sir.
So
Okay, okay,
good.
very good. So today we are going to see orthographic projections. Okay, that is very important from your examination as well as your placement point of view. These questions from this graphics basically for mechanical and civil students, these are very important if you want to get job in designs sector. Okay, so before starting, what I'll do, I have created a WhatsApp group. So the link of that WhatsApp group I am putting in your chat box. So with that link, you people can join this GDM WhatsApp group. This is first thing. Another thing that I want to tell you is I have created one Canvas invitation, Canvas course also. For that, I need your email IDs. Okay. So for that also, I have created one Google form. So I'll be sharing with you the link now. Just wait a minute. So in your chat box, now you can see one Google form link is there. Okay. So with that link, you can fill your details like your name, roll number, section, email ID, and mobile number. So with those email IDs, I will add to you Canvas, to your Canvas learning management system. Okay. So there you can get all the stuff like lecture notes, all the PPTs that I am taking, I will upload it there, video lectures and assignments, whatever we have to interact, we will interact with that Canvas. Okay, so all of you fill this Google form from where I can get the information.
Sir, email ID, student college email ID.
Yeah, college
Okay, sir.
domain, college domain email ID, because that email ID I will add in your Canvas. So for that, I'm giving you 2 minutes. Do it fast, and then we will start. So let's start with today's class, and we will start with projection. So first you need to understand what is meant by projection. Okay. So like your projectors
Sir,
that you
please
might
wait
have.
for a minute. Sir, 1 minute, sir. We are
Okay,
filling.
okay. Okay, fine. You fill it, then I will start. For the students who joined late in the class, uh, I will update you. I have posted two links on your uh, Zoom chat box. So the first link is for your WhatsApp group for the subject GDM, and the second link is a Google form in which you have to fill your. Who is this? Please mute yourself. Yeah, the second link is your Google forum where your student details are required, and from that details I will add it to you to your canvas, that is learning management system. Okay, so
Sir, where are the links, sir?
in the chat box.
Not appearing.
So those who have filled it, that is fine. Those who are not able to fill it, at the end of class I will put it again. Okay, so you can fill it.
Okay, sir.
Now we will proceed with the class, today's class. Okay, so starting with projection, first you need to understand what do you mean by this term projection. So as you can see here, one pictorial representation is there where three components or three important components are there. So you can see one person is visualizing something from this right hand side. So we will call him as observer, and then this is your object. In between you can see this is your object, and its shadow, or you can say if here we have some light source, then its shadow will be formed on this plane of projection. Okay, so this is your plane of projection. So these three things it will be common that we are going to see in today's lecture. Okay, so I will name it as first observer, here second is your object, and the third one is your plane of projection. So this is your projection or the view that you are getting. Okay, and to get that view you can see there are some light rays, line of sight. Here you can see it is written line of sight, or also called as projectors. So this term is important, projectors. Okay, what are projectors? So these are the line of sight. So basically it is originating from this position, and you can see they are the light rays, they are going from the line point of source to these corner points, or you can say corner lines, and then their projection is getting impressed on the plane of projection. So this blue color that I am highlighting, these blue lines, they are called as line of sight, or also you can say them as projection lines or projectors. So in the last class when we were studying the different type of lines, okay, at that moment you have seen projection lines. So how the projection lines are represented. If your main drawing line is, suppose this is your main line, and you are considering that its intensity is 100%, okay, this is thick continuous line, okay, your main line is thick continuous line, whereas these line of projections, they will be of little bit lighter intensity. So let me see if I have any lighter intensity line over here. Okay, so we can reduce its intensity very light. So if any line of projection is there, so it will be of lighter intensity, okay, like this. So it is thin continuous lines, okay. So this is what I want to tell you. So, and this together constitute your projection system. This is your projection system, okay. So basically your projection system here, what are the three main components? Observer, object, and plane of projection. So this you have to keep in your mind. For different method of projection, what will happen there? Their order will change. Sometimes observer, in between observer and plane, object is coming. In another case, maybe plane of projection will be in between your object and observer. That we will see in the later part of your lectures, today's lecture, okay. So now moving to the next slide. Now this one. This is another important concept that you need to understand. What are the different type of planes in your engineering graphics or your engineering drawing? Okay, so basically, as you can see here on your slide, you have two type of planes. This is your first plane that is called as principal plane, and the another one is your auxiliary plane. Principal plane is your first plane, and this is another type of plane, that is auxiliary planes. So principal plane comprises of HP and VP. So I will tell you what is HP. HP stands for horizontal plane, whereas VP represents vertical plane. Okay, so as you can see here in this diagram, this is, you can see two planes are there, they are perpendicular to each other, okay. So the one is your horizontal plane, that you can say that if you are sitting inside a room, so the floor of that room is your horizontal plane, whereas the walls of your room will be considered as the vertical plane. Okay, so this is your principal planes, horizontal and vertical. Is this clear to you?
Yes, sir.
Yes, sir.
Okay. Now coming to the next type of plane, that is your auxiliary plane. In auxiliary plane, you can see in all the three diagrams, one thing is common. That is your principal plane. Here you can see vertical plane, and this is your horizontal plane. In second figure also, this is vertical plane, this is horizontal plane. This is vertical plane, this is horizontal plane with same color coding. Okay, this is some greenish shade is there, and this is some bluish shade is there. Okay, but one extra plane is added over here that you can see in bright yellowish green color. Okay, so this is your auxiliary vertical plane. So as the name is suggesting, auxiliary, so it is not your main plane. Okay, it is auxiliary, means supplement. Vertical, so this vertical is telling that it is perpendicular to HP, perpendicular to your horizontal plane, and it is making some angle. You can see here it is making some angle with vertical plane, and that angle is represented here by a Greek alphabet phi, phi degree. It is making some angle with your vertical plane, and it is perpendicular to your HP, that is horizontal plane. So let me show you one example here. Okay, this glass system you can see. Let me stop the presentation. Are you able to see the my video?
Yes,
No,
sir.
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 Now, now it is visible to all of you. Okay,
Yes.
in my
Yes,
hand
sir.
you can see one glass kind of thing is there, in which you can see there are, if you will consider this as your horizontal plane, so this is your vertical plane. Okay, they are at 90-degree angle. Okay, so when I am placing, so that concept is simple, that is your horizontal and vertical plane. But let me explain you about your auxiliary vertical plane. See here, suppose this mobile I have taken. Now I have placed it on horizontal plane. Okay, now you can see it is, this plane is perpendicular to your horizontal plane, whereas if it is in this orientation, you can say that it is parallel to your
Parallel.
vertical plane. Okay,
Yes.
now if I'll place it like this, now see, now this plane is perpendicular to both the planes, that is your horizontal as well as vertical planes. Is it correct?
Yes, sir.
Ah,
Yes, sir.
now I will tilt it little bit, and now you can see it is making some angle. So in this view, you will not be able to visualize the angle. Let me try to show you in some other. Okay, yeah. The top view you can see it is perpendicular to horizontal plane. It is easily visible to all of you, and you can see that it is making some angle with vertical plane. Okay, so this will be your auxiliary vertical plane. In graphics, sometimes uh, we need these auxiliary planes also. Okay, so let us come again to our slides. Okay, so when it is making some angle with your vertical plane, this is called as auxiliary vertical plane. Okay, the first one. When it is making some angle with HP, you can see here it is making some angle that is theta degree. Okay, here now it is perpendicular to vertical plane and making some angle with horizontal plane. So this type of plane is called as auxiliary inclined plane. Okay, and finally you can see the orientation where this profile plane, okay, some plane is there which is perpendicular to both the planes, that is your HP and VP. Okay, So for this case, it is called as profile plane. So normally, if any object is placed above your HP, suppose here some of the object is placed over here. Okay, this is suppose some object is placed on your horizontal plane, above horizontal plane, in front of vertical plane. Okay, so we can get its front view, top view, and side view. So basically, this uh, profile plane is required to get your side views. Okay, so these three planes you must keep in your mind: HP, VP, and PP. That is your profile plane. These three planes we need to draw your orthographic projection. Okay, now coming to this plane system, or you all know that as I have shown you one uh, prototype kind of thing. Okay, where we have this. Let me take some other color. They have used pink and red. I am going to use this blue color. Yeah, this blue color you can see here. I am trying to highlight it. This is your HP or horizontal plane. Now, this blue color is your horizontal plane, and here you can see it is clearly written, it is horizontal plane. Whereas this is your vertical plane. So for vertical plane, I will take some other color. This violet color I have used for your vertical plane. Here it is written as frontal plane. Okay, for vertical plane they have used the term frontal plane. Okay, now these two planes are intersecting at some common line. These two planes are intersecting at some common line, and that is your reference line. We consider that as your reference line. Now you can see this entire surrounding is divided into four parts. The first one is your, you can see as you have seen in your coordinate geometry also. This is your first quadrant. This you can call as your second quadrant. This is your third quadrant. And finally, this is your fourth quadrant. Okay. So these quadrants are basically used to create different projection methods. So those, what are those methods? So here we have written the principal projection plane, and the quadrants are used to create first and third angle projection drawing. So this I will highlight: first and third angle projection method. Okay, so when the object is placed in your first quadrant, okay, first quadrant, when I am saying, what does that mean? First quadrant, when I am saying, let me write here. For quadrant, I am writing Q. First object is placed in first quadrant. It means it is above your HP. Okay, and in front of vertical plane. In front of vertical plane. So you can say that object is placed in your first quadrant. Okay. Now let's move to the second quadrant. In second quadrant, you can see here on, I'm writing on left top corner, I'm writing second quadrant. So who will tell me Second quadrant means above
Above
HP
HP,
and behind vertical plane. Behind vertical plane. So you can say that object is placed in your second quadrant. Okay. Similarly, coming to your third quadrant, so third quadrant means object is
Below H.
Below HP.
very good.
Below
Below
HP.
HP and
Front.
behind
Behind.
behind
Behind
V. Okay. So for this configuration, you can say that object is placed in third quadrant. Now coming to your fourth quadrant, yes, fourth quadrant means
Below HP.
below
below,
HP,
In
Front.
front of.
behind
in
In front
front of VP.
VP.
So this is your four quadrant configuration. So you can say where the object is. So if it is in front of VP and HP, so by this we can say that your concept of this HP and VP is clear now. Okay. Now using this, we will see that I have highlighted here first, and this is important, very important. First and third angle projection drawing. So what is this first angle projection? What is third angle projection? That we will see in today's lecture. And I must say here that this is very important for your examination point of view. In each and every exam, in each and every viva, question can be asked, what is the difference or what do you mean by first angle projection method? What do you mean by third angle projection method? So at here, for basic understanding, I will tell you, if the object is in first quadrant, then you can say it, we will use first angle projection method. When the object is placed in third quadrant, then you can say that we are following third angle projection method. So now question must be coming to your mind that, sir, you have told that we can use first angle projection method. You have told that we can use third angle projection method. What about this second quadrant and fourth quadrant? So that will be cleared in coming slides. Why we don't use this second quadrant method and fourth quadrant method? So we will see in the coming slides. Now, coming to theory of projection. All projection theory has two variables. Okay, means two components. You can say like that. So what are those components? First is your line of sight that we have seen in the first slide. Yeah, this is your line of sight, or you can say projector or projection lines. And the second one is your plane of projection, where it will be projected. So this is your plane of projection that we have seen in your first slide. Okay, this is your plane of projection. So basically these are the two components or the two variables in any theory of projection. Okay, now a plane of projection, here some definition is written. A plane of projection is an imaginary flat plane upon which the image will be created by the line of sight is projected. Okay, or you can say also projectors or projection lines. So those line of projections will project some image on this plane of projection, and that plane of projection is not, it is some imaginary flat plane. Okay, now who is this? Please mute yourself. Okay, now the image is produced by connecting the points where the line of sight will pierce or intersect the projection lines. As you can see here in the first slide, these line of sights were intersecting at these corner point. So through these points, we can create the image of what we have to draw. In effect, by doing this, actually what we are doing, we are transforming a 3D object. A 3D object is transformed into 2D representation. Okay, so why actually we are doing this? So our objective is to transform a 3D object into 2D representation. Okay, also called as projection. So the paper or computer screen on which drawing is created is called as plane of projection. So in the first slide, we have seen this plane of projection also. Yeah, this is your plane of projection. Now, the projection method are very important techniques in engineering drawing. There are two projection method. The first one is perspective projection method, and second one is parallel projection method. So one by one we will see both of them. Keep this in mind. First one is perspective view and the second one is parallel view. When you will be using your high-end softwares, when you move to your second year or third year or final year, so for these mechanical and civil students, these terms will be helpful because in those softwares, there will be some icon or some buttons to switch between this perspective view and this parallel view. So now try to understand what is this perspective view and what is your parallel view. Now, perspective view. Here you can see some images there where you can see some buildings are there. In the background, this image is kept here. You can see one component, a simple component you can see in green color. Let me highlight it. Some component is there in between, some hole is also made. Okay, so this is your object. Let me write here. This is your object. Here you can see observer is there. This is your observer and this is your plane of projection. This is your plane of projection. Okay, now the points that you have to keep here in your mind is here the light rays or the line of sight that is written here is originating from a single point. It is originating from a single point that you can see, and those lines are going like this, and it is going to intersect at those corner points. So you can connect all the corner points through this point source, okay? And if you will place in between your object and the observer, some plane of projection is kept in between. So these light rays will intersect on this plane to draw the projection of this object on this plane. So that projection you can see here in red color.
Repeat once again, sir.
Yeah, just wait. Yeah. What I am saying here is the location and orientation, means position of, as I have told you earlier, three components are important. First is your object, second is your plane of projection, third is your observer. Okay. Here, the from the observer you can see, or you can place a torch light. Okay. You all have torch in your mobile phone. You can switch on that torch. Okay. Let me show you. You can do it at your home. Okay. You can switch on the torch and you can place your hand in front of the torch light of your mobile camera, mobile torch. Okay. So you can see the shadow of your hand will be formed on your back wall, backside wall. Okay. So here, for this particular example, your observer is your mobile torch, object is your hand, and plane of projection is the wall that is behind your hand. Okay. Here what I did, I have bring the plane of projection just between the observer and the object. So when the light rays are going, connecting, suppose you have to connect all the corner points of the object. I am highlighting in red color all the corner points with this light source. Okay. So when you will connect this straight line, this is your line of sight, or you can say projection lines. So on this plane of projection, it will cut, and when you will join it, you will get the image or the shadow of that object. Okay. So
Yes.
the thing here is, first is the observer, the light source is point light source. Okay. It is originating from a single point. Okay. And this is expanding. Suppose this plane of projection I have kept here. So the image that is formed on this plane of projection, here you people now tell me, this image is smaller than this object or bigger than that object for this case?
Bigger.
Bigger.
Smaller.
Smaller. Here for this case, it is smaller. When it will be bigger? When you will keep your plane of projection just behind or behind your object. Okay. Then your light rays will go on like this, and then you will be having some bigger object, bigger image. Okay.
Yes.
So by changing the position of your light source, okay, by changing the position of this observer, you can change the size of your image also. Okay. Or by changing the position of this plane of projection, you can change the size of your image also. Okay. So the first thing is I will write here. Observer or the observer is nothing but for this case is a point light source. Okay. The second thing is here you can see the light rays are making some angle with each other. Okay, they are not parallel. So I will write line of projection lines or projectors. Projection lines are not parallel to each other. This is second point. Now, third observation, what I did here is the image formed is either smaller or large or bigger in size. Okay, when smaller when the plane of projection is in front of your object, and when bigger size you will get when your plane of projection will be behind the object. Okay, so these are the 3 points that we have observed here. It comes into your perspective projection. Or for a practical example, if I'll give you, suppose you are standing in front of your street where a series of houses are there and a straight road is there. Okay, so by standing at one position, you can see, suppose there are some lamp posts, I will draw or highlight here in red color. Okay, so this is suppose your another lamp post, and suppose here is one more lamp post. If in between there are some, so normally it will look like this and it will go on. So what you are observing here, the lamp post which is closer to you, it seems to be little bit larger, whereas the lamp post which is little bit far away from you, you can see it smaller. Okay, so this is our real eye view. This is our real eye view. So this perspective view or perspective projection is also called as real eye view. What we see through our eyes, that is your perspective view. Okay, whereas in the case of, so that statement is written here. Let's see. The distance in perspective projection, the distance from the observer to the object is finite. Okay, so you can keep this in your mind. Going to the previous slide, here you can see this distance, the distance between this observer and the object is finite. It means you can measure this distance, how far the object is there from the observer. Okay, so the distance from the observer to the object is finite. Finite means measurable. You can tell that the object is around 200 meters away from me. Okay, so it is some finite length, and the object is viewed from a single point. Projectors are not parallel. Projector means your line of projections, they are not parallel. Okay, so we can say perspective projection mimics what the human eyes see. Okay, what we see from our human eyes, that is the mimic, or you can say your perspective view. Okay, however, they are difficult to draw on the drawing sheet. So we use another method, that is your parallel projection. Just give me one. Okay, so that's why this is your second type of projection system, that is your parallel projection system. Here, what you can see, all the line of sight or your projection lines, they are parallel to each other. Here you can see. The projection lines or the line of projections, they are all parallel to each other. Okay, and when, at what condition you will get these parallel lines? It happens only when this observer it happens only when this observer is at infinity. Infinity, it means when the light source are coming from infinite distance, then those light rays will be parallel to each other, and when they will pass through those corner points, then you will get some image. This is your image that is projected on this blue color is your plane of projection. Okay, so let me write here, this blue color is your plane of projection, and this is your object. Okay, so one more thing that you can observe here is the size of image and the size of object, they are exactly same, since the light rays are coming from infinity and they are parallel to each other. So whether you keep your plane of projection at this location or you keep your plane of projection behind the object, the size of image you will get, it will remain the same as of your original object. Okay, so what are the observations? The first is your, we can see in the previous slide what I have written. Here observer was a point light source. Here the observer is at infinity. So I will write observer is at infinity. Second observation, line of projection. Line of
Parallel.
projections are parallel. Okay. Third is the size of image is same as of the original object. So this is your parallel projection method. This is comparatively simpler to the previous one, okay? And we use in your engineering drawing this method, parallel projection method. So this is the method that we use in your engineering drawing. So its statement is written here. Distance from the observer to the object is infinite. Projection lines are parallel. Object is positioned at infinity. You can keep object or you can keep observer, anything, okay? So then only you will get this light rays or projection lines as parallel, okay? So this is called as your parallel projection. Now it's 11:50. We will take a break of 10 minutes and then we will carry forward with our first angle projection method. Okay. So the time is 11:50. I want you people all to join again by 12 o'clock. Okay. So we will not disconnect the meeting. I will simply put it on mute mode
Sir, 1 minute,
and
one
we
minute.
will yes.
Sir, that two types of projection before slide once display, sir.
Yeah.
Two types are
This is
classified.
yes, yes. Okay.
Before one, sir. Before. Yes, sir, this one. Now, sir,
Uh,
next one.
what is your question?
Ah,
You asked me. This one. This
No,
is
sir.
the two projection methods that we are following.
No, sir. Same two are classified. No, sir. In previous one.
Which one? Now you can see here the slide number also on the left hand side. Okay. Now you tell me of which
51,
slide.
sir.
Huh?
51, sir.
Which number you tell me again?
5, sir. Fifth one.
Okay, fifth one. Okay. Yeah. Here.
Yes. Okay, sir.
These are two components, or you can say two variables of theory of projection. Like in when we were discussing your plane and perspective view, then we have seen this line of sight and this plane of projection. Okay, so these two, and I can add here one more also, that is your observer. That is also one of the very important point. This is also one of the variable based on their position, like where the line of sight is there, where the plane of projection is there, and where is the observer. We basically decide the different projection method. So two projection method we have discussed, perspective and parallel. Now
Yes.
this perspective is the mimic of your real eye, what we see through our natural eye. And this parallel projection is when the observer is at infinity, or means the line of source are parallel to each other. Now, in this method, it will be further classified into first angle projection and your third angle projection. So that we will see in the coming slides. Okay.
Okay. Okay, sir. Okay. Okay, sir.
Okay, so we will take a short break and then we will start again. Okay, so all of you by 12 o'clock join the class once again. Okay, welcome back. So now we will see the different projection methods. That is your first angle projection method and third angle projection method. For the students who joined late, once again, I will post that links for your WhatsApp and your Google forum. This is the link for your Google form. Some student I can see he has posted that it is asking for you need permission to fill this form
Yes, sir.
because you are using your personal Gmail ID. You have to use your college Gmail ID, then it will not ask like that. You try to log in again with your college domain email ID, then you click on that link, then it will work. So that WhatsApp group link also I have shared, and Google forum link also I have reshared. Okay, now let's start. Now here you can see yeah, here you can see one object is there. This is our object. It is already in red color, so I have to use some different color. Okay, this is your object. One rectangular box is kept over here, and suppose your observer is on this side. So let me write here, the observer is viewing this from this side. Okay, so this is your observer. Okay, if this observer is viewing from this side, so from infinite distance those light rays are coming. So now we can say they are parallel to each other, and when they are parallel to each other, then they will be passing through these corner points, and you can see here in light green color they are intersecting on your VP. This is your VP, vertical plane. Okay, and it is, you can see or you can visualize this blue color rectangle is there. That is your FV, means front view. So the front view of your object you can see on vertical plane. Similarly, when you will see it from the top, you will be able to see this smaller rectangle from the top. Okay, so this will be your light rays will be coming through this, and it will project over here. Again, you can see in light green color, I am trying to project those projection lines. So you will get your top view on horizontal plane. On your horizontal plane, you are able to see your top view. This is your top view. TV. TV stands for top view. Whereas FB is your front view. So where you are able to see your front view? On vertical plane. Where you are able to see your top view? On horizontal plane. Okay, now this side, this is our left hand side. When the observer is viewing from this side is your left hand side, So from this side, the line of projection will go like this, and you will get this view, that is your
Side
side
view.
view. And it is projected on, who will say,
Project profile.
profile plane. Okay, so one thing you have to keep in your mind, that observer is looking from this side, and this is the left hand of your observer. So let me write here, left.
Sir, I'm having one doubt, sir.
Please tell me your doubt.
Sir, how at a time two top views can be, sir? There should be bottom view, no, sir.
No, 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 no,
Green
no, no.
color.
This green color, this is only one top view.
Then that blue arrow, sir, for top side TV.
Where is that blue arrow? Yeah, here. So when you will be able to see your top view? Suppose uh, you want to see the top view. So what is the top of this object? This is the top. Okay. So observer, if is on this side, so for him this is the top. Okay. So what will be its projection? So for that you have to switch on your torchlight from above, so that your shadow you will be able to see on this horizontal plane. Okay, suppose you want to draw the bottom view. So bottom view is not visible from this side, but suppose this is, it will be like this. One rectangle will be here. So for bottom view, you have to keep your light source in this direction, and then it will go somewhere, uh, some profile plane you have to draw above this object. Clear?
Clear, sir.
Okay. So here in this first angle projection method, the object is assumed to be situated in first quadrant. This is very, very important. Okay. So object is assumed to be situated in first quadrant. So first quadrant means above HP, in front of
VP.
VP. Okay. This is your first quadrant. Okay. Now it means, oh, it is written here, in above HP, in front of VP. And object is in between observer and the plane. Now order of your these variables, here is your observer, here is your object, and this is your plane of projection. Okay, so the
Sir,
object is, yes,
observer is at infinite, sir. Distance
yes, then only you will get this
equal.
parallel
Yes, sir.
parallel line of projections. Okay,
Yes, sir.
so this is, I will write here one point number one. Now point number two is object is in between observer and the plane. Okay, now you can see if these planes, that is your vertical plane, horizontal plane, if they will be connected, at what line they will be connected. So this line will can be a common line to both of them if we have to join this vertical and horizontal plane. Okay, similarly, if you have to join this profile plane and this horizontal plane, so this will be your common line that can be connected. Okay, and for this vertical plane, this side and this side will be connected. Okay, so if all those things are connected and you will open it, so you will be able to see this is your vertical plane, this is your horizontal plane, this is your profile plane. Okay, what we are doing, we are opening this, let me choose some other color, green color. Okay, see, What we are doing? We are opening this profile plane in that direction. Okay. Similarly, we are opening this also, this horizontal plane. See here, we are taking this down. How we are opening this, we will discuss in later slides. Okay, then you will get a 2D plane surface like this. Okay, and this common line is your reference line, or it is represented by xy. Another thing is, you have seen this is your vertical plane, you have seen this is your horizontal plane, you have seen this is your profile plane. Okay, so in your vertical plane, which view is there?
Front view.
Front view. On your horizontal plane, which view is there?
Top.
Top view.
Top view. So another thing you can see here, the front view is above your reference line. Okay, and the top view is below your reference line. And you can see here LSV means left hand side view, left side view, which is located on right hand side of your front view. Okay, so this you can keep in your mind. When your light rays are coming from this side, then only the shadow will come to this side. So that's why your left hand side view is coming to the right hand side of your front view. This point you have to keep in your mind. Okay, is that clear to all of you?
Sir, here where is reference
Sir,
line?
repeat the last point, sir. Left hand side.
Okay, so two questions have arisen here. The first question is, where is the reference line? So the suppose this is your line, this we can connect to this. Okay, so this is your reference line. So through another slide, I will explain you where is, see here. This is your front view, vertical plane, where you are able to get your front view. This is your horizontal plane, where you are getting your top view. These two planes are intersecting each other at a common line of intersection. So this is your reference line that is represented there in XY. Okay. Now, the second question that is left hand side view. So for your memory, you keep in your mind, for first angle projection method, okay, for first angle projection method, you will always get left hand side view on the right hand side of your front view. Okay, suppose you want to see the right hand side view of this object. So light rays will be coming from right hand side, and the image or the shadow will be formed on the left hand side of your front view. Okay, so let me clean it, then I will explain it one more time here. Because this is very important point, normally asked, we used to ask this in Viva. So I am explaining it once again. The thing that you can keep in your mind is, always remember, for first angle projection method, okay, left hand side view, right hand side view, it is V. Okay, left hand side view, right hand side view. So left hand side view will appear to the right hand side of your front view. Always keep in this mind. Okay, it will come to the right side of front view, whereas your right hand side view will come to the left of your front view. This point you can keep in your mind. So the first difference is the object is located in first quadrant. First quadrant means above HP, in front of BP. Second point that you have to keep in your mind is object is in between observer and the plane. Okay. And the third difference is your front view. Where is your front view? Your front view is above XY. XY or reference line you can write. Where is your top view? Top view is below XY. Okay. So these things you can keep in your mind for first angle projection method. Now, actual pattern of plane and view in first angle method of projection. So this is what I have to say for your first angle projection method. Okay, if the things that I have told on this slide is clear to you, then we will move on to the next example. Whatever I have told is clear to everyone. Please write in your chat box CS. CS represents clear, sir. Let me see how many of you are actively listening to the classes. We have the strength of 44 participants. I have received 25 responses. So rest of the students, it means they are not actively listening. So everything is recorded. We can see here what are those roll numbers, they are not responding. So ultimately, when the time will come for your day-to-day evaluation, some score is there, 20 marks, 10 marks. I will explain it in further classes. So at that moment, you will lose some marks. Okay, 31 responses. Still 12 to 12 responses, 12 people are inactive. Yes, one student is asking, common line is called as reference line. Is it right, sir? Yes, it is exactly right. The common line of intersection of your vertical and horizontal plane is called as your reference line. We will see in the next coming slides. Okay. Now, principle of projection. Let's see the theory. In all of you, please pay attention. Okay. If straight lines are drawn from, let me move this video. Yeah. If straight lines are drawn from various points on the contour of the object to meet a plane, the object is said to be projected on that plane. So whatever we have discussed now in the previous slides, for that, this is the points or takeaway points that you can keep in your mind. And the figure formed by joining in correct sequence the point at which these lines are meeting is called the projection of the object. Okay, that we have already seen. These are your projection of the objects. This is your projection of the object. This is your projection of the object. Okay, now the lines from the object to the plane are called projector. This is called as projector, or also it is called as projection lines. Okay, in engineering drawing, there are four methods of projection. Okay, we have studied their parallel and perspective projection. In parallel projection, we have four method of projection. Okay, what are those four methods? orthographic projection, isometric projection, oblique projection, and perspective projection. Oh, okay, okay. Let me correct it. Uh, we have seen their perspective and your parallel projection. Okay. So here we are looking orthographic, isometric, oblique, and perspective. So now I will explain you what are these four projection methods. Okay. In your syllabus, only you have to study this orthographic projection and your isometric projection. These are the two that is in your syllabus that you have to study. Now try to understand what is this orthographic projection and what is this isometric projection. Now when we are drawing that 2D representation of an object, okay, like in the previous slide we have seen that we have drawn the front view above your reference line, top view below your reference line, suppose this is your xy, and also we have seen on the right hand side of your front view you have left hand side view. Okay, so here what we did actually, here we have represented an object or 3D object on 2D plane. So this is called as your orthographic projection. Okay, in orthographic projection what we are doing, an object is represented by two or more views. What are those views? Front view, top view, or side view. Okay, so all of you keep this in your mind. What is orthographic projection? 2D representation of any object on plane of paper or computer screen, that is your orthographic projection. Okay, so this is, I can write 2D representation of 3D object. Okay, now the remaining three versions here you can see perspective, oblique, and your isometric projection. They all are 3D representation. Okay, in the above method, 2, 3, 4 represent the object by pictorial view as our eyes see it. What you see from your eyes, okay, those 3D representations can be shown by this isometric, oblique, or perspective. Okay, in these methods of projection, a three-dimensional object is represented on a projection plane by only one view. Now, what is that one view? I will show you with example. Here in this figure, you can see if I will tell that I will use red color. Yeah. This is my. Please mute yourself. This is your object. Okay, this is your 3D object. So here we have represented that 3D object, and this is your called as isometric view. Whereas it's, you can see using those projection lines, this is your front view that is projected on your vertical plane. Okay, so this is called as its projections, that is your front view or top view or side view, they are called as orthographic projections. Good question. 1026. Don't unmute yourself. There are so many disturbing noise are coming from your side. Okay. So if you people have to ask any question, you can use this chat box. You can type your question on this chat box. Okay. Until or unless it is not required, don't unmute yourself. Okay. So we were talking about this orthographic projection and isometric projection. So these two things you have to understand and keep in your mind. What is this orthographic projection and what is this isometric projections? Okay. So when you are representing a 3D object on 2D plane, like using your front view, top view, and side view, that projection is called as your orthographic projection. And when you are representing a 3D object on your plane of paper, that is your isometric projection. Each projection view represents two dimensions of an object that we will see in the next slide. And the complete description of three-dimensional object requires at least two or three views. Okay. So
Once
see
again, please
here.
say difference, sir.
Yes.
Once again, please say difference between those 1 and 2.
Okay. See here in this figure, as I have told you, this this is the 3D representation of your object. Okay, where suppose observer is standing on this side and looking at this object, the object which I have highlighted with red color. Okay, so this face he will be able to see from the front side. Okay, isn't it? So this projection you are able to see here. So you can say that the drawing that I have drawn here on the back side, this is front view of this object. So this object, this 3D object, rather that I have written here isometric view, let me write here 3D object. Okay, this 3D object, its representation here you can see is in 3 dimensions, where you are able to see all the dimension. What is the height? The height of this object is represented by capital H. What is the width? So you can see here it is represented by capital W. And what is the thickness of this object? It is represented by capital T. So in this, for this 3D object, you are able to see all the 3 dimensions in a single figure. All the 3 dimensions you are able to see in a single figure. That is your 3D object. So this view is called as your isometric view. 3D view of the object is called as your isometric view. Whereas its projections, like you will see its front view like this. This is your front view. Let me choose some other color. On the right hand side, you can see here, this is the front view, what you can see there. This is called as your orthographic projection. Okay, so what is orthographic projection? Front view, top view, and side view. When you will see that, that will be your orthographic projection. Okay, so in simple language, if you have to keep in your mind, I will write here on left hand side I have written isometric view. So on right hand side here I will write orthographic view.
2D projection is also called as orthographic, no, sir?
Yes, exactly. Orthographic projection. So this is nothing but 2D representation of your 3D object. So how you will represent 2D representation of 3D object? So for 2D representation, what are the views that you require? You
Front
require
view, top,
front view, top view, and side view.
side view.
Why three views are required? Because three or two views are minimum required. Why? Because in front view here you can see only two dimensions. The height you can see here, the width W you can see here. But in this front view, you will not be able to see how much is the thickness of this object. For the thickness, you have to go either the top side or you have to see it from the side view. Then you will be able to see this dimension. What is the thickness of this object? Okay. So when the projectors are parallel to each other and perpendicular to the plane, the projection is called as your orthographic projection. Okay. Now, coming to little bit more descriptive picture. Here you can see that this is your vertical plane. And this is your horizontal plane. Okay. Now, we all know that they are at an angle of 90 degrees. In the previous slide, you have observed that if the observer is looking from this side, so you were able to see this face. Okay, this face you were able to see on your front view. So that projection you have observed here. With the same color, I am hatching it. Okay, so this is your front view. Now, if we talk about your top view, so let me use red color. What are the faces that you will be able to see? So this face you will see from the top. You will not be able to see this face from the top, but you can see this one. And again on this side there will be a rectangular portion. So from this side we are able to see this much only, but there will be some rectangle. Okay, so that projection you can see here. This is your first rectangle, second rectangle, and third rectangle. So that red color you can see here. This is your first rectangle. Again, this is your second rectangle. And this is your third rectangle. So the red color portion, what I have drawn here, that is your top view. Means if you will look this object from the top or from the above, you will be able to see these rectangle. Okay. So now this is 3D. This is 3D. You can see here. But how to represent it in 2D plane? Because our paper or the drawing sheet is 2D in nature. So what we will do, we open this like this. You can see here, A is written. So we move this in that side and we move this in this side. Okay, so you will get then a 2D representation that you can see here on your right hand side. This is your vertical plane and this is your horizontal plane. Normally in this direction we used to open this, and this is your horizontal plane and this is your vertical plane. Now what this red color top view you have observed there, it is the same. From the top you will be able to see this rectangle, and for the front view, this is the shape that you have observed. So this is how we can convert, or we can open the 3D three quadrant system. So this is your front view and this is your top view. Okay, so this is your XY. What is XY? Here you can see the front view or the vertical plane, and this horizontal plane is intersecting at this line, common line you can get here. So that is your XY. Okay, now which dimensions we are able to see in which view? So the height of the object you can see here in front view, the width of the component you can see here, okay, in front view. So I will write here in front view, two dimensions you can see, height h and your width w. Whereas for this figure, in your top view, you are able to see what is the thickness of the object. Okay, so the orientation you can see here, horizontal plane is moved in which direction? In clockwise direction. To open it, whereas we opened it in anti-clockwise direction. Okay, to get the 3D representation of the planes in 2 dimension. Now you can see here, these are our 4 quadrants that we have already studied. First quadrant, this is your second quadrant. First quadrant above HP, in front of BP. Second quadrant above HP, behind vertical plane. This is your third quadrant, below horizontal, behind vertical plane. And this is your fourth quadrant. Okay, now as I told you in the previous slide, this is 3D representation of the entire planes. When we are converting this, what we are doing? We are opening this in clockwise direction, horizontal plane. Now from here you will get that answer. Why we only observe in first quadrant and third quadrant? Okay, I have told you in the previous session. And this horizontal plane will open up in clockwise direction like this, whereas you can see here this vertical plane will open in this direction. In anti-clockwise direction. So what will happen? What will happen? They
Overlap.
overlap. Yes, exactly correct. So if you are keeping something in second quadrant, so what will happen? The top view and front view will overlap on each other. Exactly will same happen when your object is in fourth quadrant. They will overlap on each other, the front view and the top view. Whereas it will not happen when the object is in first quadrant and third quadrant. Okay, this is the purpose of showing you this figure. Now, let's see what is written over here. The two planes employed for the purpose of orthographic projection are called reference plane or principal plane. We have already discussed. They intersect each other at right angle. So we all know that this angle is 90°. You can see the two corners of your wall. They are intersecting each other at 90°. The vertical plane of projection in front of observer is usually denoted by VP, that is your vertical plane, and it is also called as frontal plane, represented by FP. This is your horizontal plane, represented by HP. The line in which they intersect is termed as reference line, denoted by XY line. Projection on VP is called front view, okay, or elevation. So keep this in mind. Here, one more term is coming into picture. Front view, or front view is also called as elevation for civil engineering student. Keep this in the mind, because in your civil engineering term, normally they used to call elevation and plan, and so top view is also called as plan. Okay, so this you can keep in your mind. Now, this is the example where the object is placed in third quadrant. Okay, here you can see now that same object is placed in third quadrant. Okay, so from this side, observer is looking. So what is the order now? This is observer. After observer, you can see the plane of projection is coming in between. This is your plane of projection. So I will write here first, the second plane of projection, and finally your object is coming at third location. So this is the order. Okay, and you can see when the light rays are going, this is your front view, and this is from the above side, this is your top view. When you will open it, this horizontal plane normally goes in clockwise direction, whereas this you can keep it like this only for this case. So what you will observe, when the object is placed in third quadrant, top view is coming above your reference line and your front view is coming below your reference line. Keep this in mind. Exactly reverse is happening here. Okay, the shape will remain the same, but the top view is, suppose this is our paper, This is our reference line XY. So when the object is placed in third quadrant, your top view is above reference line and front view is below reference line. When this case is happening, when the object is placed in third quadrant. Okay. Whereas when your object was placed in first quadrant, yeah, here, when the object is placed in first quadrant, where I wish right here, first quadrant, then for this case, if this is your A4 size paper, you are drawing one XY line over here. So the front view was going this side and top view was coming to below the reference line. So this is now we are going to study the difference between your first quadrant or first angle projection method. This is called as first angle projection method, and when the object is placed in third quadrant, then it will be called as third angle projection method. Okay, so today we will stop here and we will discuss in detail about few more differences between your first angle and third angle projection method that we will discuss in next class. So till now, if you have any doubt, you can ask me, or if you have no doubt, you can type in the chat box, clear sir.
Sir, once show those last picture, sir.
Which one?
Just now you have removed.
This one?
No, sir, last
Okay.
overall pictures are there, sir.
Overall picture.
Completely. No, sir, you're coming.
Okay, okay. You tell me the slide number. Okay. Yeah, here on this side, you tell me the slide number. The second.
Please scroll down. Scroll down, sir.
Yeah, we have discussed only up to slide number 17.
Okay, sir. I thought it was 18th, sir.
18th we have not discussed.
Okay, sir. Okay, okay.
Okay. So this we have seen today what is your first angle projection method and what is your third angle projection method. Once again, I will send you that Google form link as well as your, let me copy it. In the chat box, I have put your Google form link. You can share with your friends. I will post it in your WhatsApp group also. Those who are not able to post, you can share it with your friends. So with this data of email address, what I will receive here, I will send the invitation for your Canvas LMS. So that's all from my side today. Someone is saying, can you send the PPT in WhatsApp group? No. Whatever I have to share, I will share it in your Canvas. All the study material, all the recorded video lectures, you can get it from your Canvas. We will use that WhatsApp only for any information that we have to communicate. For your all study materials, you can check your Canvas. So that's all from my side. Have a nice day I'm going to stop this meeting.